I just finished a workout, and I am exhausted, but I'm trying to get into shape. I'm trying to gain weight too, so I'm trying to eat tons. I'm trying to get lots of protein because I want to build some muscle, but I'm also trying to eat just more calories than I'm burning because I want to gain weight, which is going well. I gained 5 pounds. I'm at 105 now, and I'm very proud about it. I have been trying to get over 100 for like a year now, and I'm very proud of myself. Ever since I came out of the coma, I have been working towards getting healthy again, and so I feel very accomplished. But I was just watching this video that was explaining that basically I know nothing about water. Liquid water, like the reason that it exists the reason why it's so bizarre and has so many properties that are unique to it, it was always explained by just a generic, like it's because of the hydrogen bonds. It's because, like the hydrogen bonds between so like in water molecules, which are H2O molecules, there's the one oxygen molecule in the middle, and then there's the 2 hydrogen molecules on the outsides. And hydrogen is a tiny molecule. So they are very small on the outsides, but they pull on in water, the way that it bonds, basically, it has like a kind of a charge towards the hydrogens where they can like attract each other like little magnets, and those are called hydrogen bonds. And so it basically makes water stick to itself. So it gives it high surface tension, it gives it an unusually high boiling point for a liquid, or for like such a small molecule. It also has just weird properties, like because it expands as it freezes, it gets less dense. So instead of sinking when it freezes, it floats. It has lots of weird properties like that. But I was just watching this YouTube video that was explaining that it's not just that the hydrogen bonds are like making it adhere to itself to give it higher surface tension to allow like a lot of animals to literally walk on water and like make it unique to like life needs it for some reason. It actually has 2 liquid states. They call it like a high density state and a low density state, but it exists in 2, and like I think it was 40 degrees Celsius. It might have been like 41 or something, but it changes from one phase to the next, and like it exists in liquid form between those 2 states, and you can actually. So liquid water naturally exists between these 2 states, and you can separate them out from each other. You can separate one from the other, and it has the high density state. It has like it's a random configuration like a typical liquid, but the low density state, it's like it forms this open structure that's like loose, but it takes up more space in general than the undefined structure. So it ends up being less dense as it becomes more ordered, which makes sense for water because it gains density as it freezes. Or like it loses density, it expands as it freezes. And so as it becomes more orderly, like it would in a solid state, it like forms these open structures that end up being less close together than when it was just randomly packed together. Because water molecules are very, very small. Like if you randomly pack them together, they can get like, marbles can just, when you put them in, they, no matter what, they're right next to each other. Like they're just like a circle, they're not weirdly shaped or anything. So like water can pack in like pretty close, and it pulls to itself pretty closely. Like you basically can't affect the density of water because it just wants to do what it does. But I cannot believe, like I am 31 years old, or well, I'm turning 31 in September. I'm 30 years old. I'm a 30-year-old man, and I have been to college, like I consider myself well educated. And something as elemental as water, I'm learning has a state that I'm just hearing about for the first time in the middle of the night. on a Wednesday. What? That's pretty cool. I think science and learning is just so fun. What else gives you that? That feeling, huh? Tell me. So usually water, just like with state changes or phase changes, usually there's a large energy barrier to jump from the high density to the low density state. There's like an energy barrier that it has to cross before it can make that state change. There's a boundary, basically, but there seems to be other pathways that it can take, like under like specific conditions, like for example, an extreme cold. Like if you if you cool water below its freezing temperature. So if you super cool water, apparently it can jump back and forth between these states easily, and so they. There's a lot of things that I was learning for the very first time about water, which is something, I mean, you couldn't get more basic than that. But thinking about then why it's so essential for life and whether life could theoretically exist without it, this is like a major piece of that puzzle. Like we could, I'm so interested, to look into like the properties of these two different phases of water, like the two different states. And I don't know, I just think that it's so fascinating. It's crazy to me that at 30 I could still be learning so much, but I think that that's what's fun about science. And then there's just always more to learn. And I hope that you learned something, and I hope that you had fun as well.